Hey crew, it's SAT Hijackers back at it again, hijacking the SAT one problem at a time. Geometry can be weird, but it doesn't have to be painful. In this video, I'm walking through real SAT geometry problems and showing you how to break them down step by step. Whether you're feeling confident or completely confused, you leave this video knowing more than you came with. Let's figure it out together. So here we have a triangle problem. The question states, in the right triangle shown, what is the value of sine A? So I'm going to draw SOHCAHTOA quickly as we're dealing with trig ratios. Always remember, whenever we're dealing with trig ratios, you want to use SOHCAHTOA to help you guys remember what our trig ratios are. So we have SOHCAHTOA up here. So I'm going to draw sine A is equal to opposite over hypotenuse. And that's what our trig ratio is for sine. So we have sine A over here. So we have sine A is equal to opposite over hypotenuse. So now we want to know what our opposite and hypotenuse sides are. So 171 is directly across from our 90-degree angle, so we know that's our hypotenuse. And we have 35 that's directly across from the angle, from our angle theta. So we have angle theta or A in this context. So our opposite side is 35 to 35. So we have sine A, which is opposite over hypotenuse. We know what our hypotenuse opposite are, so we can put it as 35 over 171. Therefore, our answer is B. It's a very simple question. You just have to identify your opposite and hypotenuse parts. Here we have a circle problem that states a circle has center O and points R and S lie on the circle. In triangle ORS, the measure of angle ROS is 88 degrees. What is the measure of angle RSO in degrees? So I've already drawn the diagram, so now I'm about to label it. So we have angle 88 at point O. We have our sides written as R and R. So we know that O to R and O to S is the radius, so both sides are R to R. And because both sides are the same variable, that means they're equal to each other. So R is equal to R, which makes this an isosceles triangle. And an isosceles triangle has two sides that are congruent to each other. Therefore, in an isosceles triangle, when two sides are congruent to each other, that means two angles are congruent to each other as well. So it can say angle R and S are congruent to each other. Therefore, we can write an equation for the angles inside the triangle. So 180 degrees is the amount of angles inside a triangle. Therefore, we can say 180 degrees is equal to 88 plus 2x, as there's two of the same angles, each one represented as x. And we're going to run a two-step equation, which subtract 88 from both sides. 88 from both sides. And we get an answer of, this should be 92. So 92 is equal to 2x. 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 So you divide both sides by 2. Therefore, we have x is equal to 46 degrees. So here we have what would be considered one of the easier questions from the SAT. Question states, rectangle P has an area of 72 square inches. If a rectangle with an area of 20 square inches is removed from rectangle P, what is the area in square inches of the resulting figure? So I already have rectangle P drawn for you. So we're going to draw a rectangle with an area of 20 square inches that is inside our rectangle P. So I'm going to section rectangle P and we're going to put our sectioned off 20 inches rectangle as rectangle Q. So we know the total area of rectangle P is 72. So we're going to write this total area 72. You know this section, rectangle Q, is 20. So here in this question, we can see that the rectangle that is removed with the area of 20 square inches is going to be labeled as rectangle Q, which is what we have in the diagram on the right that was labeled. So now we can write equation for the resulting figure. So we can say rectangle A, which would be a resulting figure, is equal to 72 minus 20, as we're removing from P, so we're going to subtract. So 72 minus 20 is equal to 52. Therefore, we have an answer of D. So here we have a 3D problem. The question states a cube has an edge length of 68 inches. A solid sphere with a radius of 34 inches is inside the cube, such that the sphere touches the center of each face of the cube to the nearest cubic inch. What is the volume of the space in the cube not taken up by the sphere? So here I already have my diagram labeled. So we have our edge length as 60 and our radius is 34. So I'm going to draw the volume of a cube, which is sides cubed. I'm going to draw the volume of a sphere, which is 4/3 pi r cubed. So now we're going to input our variables for edge length and radius into our equation. So we're going to have volume of a cube is equal to 60 cubed, which is equal to 314,432. So that's the volume of our cube. So now we have to find the volume of our sphere. So we're going to input r into our equation. So we're going to have 4/3 pi 34 cubed 34 cubed. So that's our going to be equation for a volume of a sphere. Now we're going to simplify. So we're going to get 39,304. So now we're going to multiply that by 4/3. And now we're going to multiply that by pi as well. So now we simplify even further. So we're going to distribute our pi to our 39,304. So we're going to have 4/3 123,414. We're now going to distribute our 4/3 to our number. So we're going to get 164,552. So this is going to be the volume of our sphere. So now we want to find the total volume that is not taken up by the sphere. So volume not taken is going to equal the volume of the cube minus the volume of the sphere, as we're removing the volume of the sphere from the cube. So we have to use subtraction. So now we're going to input our numbers. So we're going to get 314,432 minus 164,552. And that's going to equal 149,880. And then answer that close nearest fits that is answer A. So therefore our answer is A.